Very often when you are working with data, your data is not going to come neatly in a single table. Rather, you're going to have to aggregate it from multiple sources and merge it together. This is the concept of joining in data analysis, and that's what we're going to be focused on in this video. So let's get started. So I've opened up my folder here on VS Code, and I'll go ahead and make a new file, and let's call it pandas merge.qmd. So merge is the function that's used for joining within pandas. And the first thing we'll do is we'll make a section and call it data and packages. And we're going to paste in a very big chunk of code in here. So this will be made available for you in the lesson script under the video. And what this is doing here is we import pandas as PD. And then we're reading in some data from the internet. But in addition, we are also creating a bunch of tiny little data frames that we're going to use for many of the illustrations. So copy and paste in that code and make sure to run the cell. And now let's open up a new section and call it why do we need joins? So let's try to give a motivating example for what exactly a join is. So I'm going to put in a data frame here called people that was defined at the start. So type in people and then run that so you can quickly view it. You can see we have 3 people, Alice, Bob, and Charlie, ABC, with their names and ages. And then let's also print another data frame called test info. And this contains the test information for Alice, Bob, and Charlie, their test date, and whether the test came in positive or negative. And this toy example gives you a sense of the kind of data you may want to combine. So we may want to have all of this information in a single data frame so we can analyze their ages and maybe how it relates to their test results. Of course, in the real world, you would have thousands or hundreds of thousands of rows, but here we have just 3. And let's see how we can work with this. So one function I'm going to show you is the pd.concat function, pd.concat. What pd.concat does is, like it says here, concatenate pandas objects along a particular axis. And we can give it arguments as a list. So here I'm going to try to combine or concatenate people and then test info. And I'm going to set the axis to be 1. So that will just combine the columns. So axis here equals 1. And let's see what happens. So what this function does, as you can see, is it literally pastes the 2 data frames together. So it takes this one named age and it copies the second data frame and puts it right beside the first data frame. But as you can see, this is not a very good way to join these 2 data sets. For one, because now you have 2 duplicate columns for name. So that's pretty annoying. And let's see another problem with this kind of naive approach of simply pasting the 2 data frames together. This will come up with this test info disordered data frame. So let's print test info disordered. And now, as you can see in test info disordered, instead of ABC, Alice, Bob, Charlie, we have now Bob, Alice, Charlie. And so what's going to happen if we concatenate again? Let's take a look. I'll copy this concatenation code and let's paste it down here. And instead of combining with test info now, let's combine with test info disordered. And you will see that we have a problem because now Alice's information is combined with Bob and Bob's with Alice. So as you can see, what we want is not a naive pasting approach. We want something more intelligent wherein whatever the order of the rows are in datasets A and B, the correct rows can still find themselves and join appropriately. And there's another issue that will come if you just try to naively paste the 2 data frames together. And to illustrate this, let's open up another code chunk and let's print the test info multiple data frame. So now with test info multiple, you can see that Alice took 2 tests. And this could be possible, right? Alice could have multiple tests. And now how are we going to paste these 2 pieces of information together? Let's try that. So I'm going to copy again pd.concat and open up a new code chunk. And let's try to do this concatenation and see what happens. So as you can see now, the whole thing is broken because Bob is matched with Arlie, Charlie is matched with Bob. And for this last row here, we have no equivalent name and age. So clearly we need something more intelligent. And that more intelligent procedure is called joining. And it turns out that in pandas, for some reason, the function that you use to join is called merge. So merge is what you use to execute joins in pandas. And let's see now how we can use pd.merge. So I'm going to call pd.merge, and we're just going to grab the different examples that we tried out. So first, people and test info. And if I paste that in here and run it, you can see that, of course, it will work out fine. And notice now the name column is not duplicated. Very nice. Let's try it also with the disordered version, test info disordered. So if I run this, you can see it still works out perfectly. So the merge function is able to find the equivalent rows for each of the individuals. And finally, let's try the multiple version. So test info multiple. And if we run this, you can see that very nicely. Alice had 2 tests, if you recall. And now her information, her demographic information, age 25, has been duplicated for those 2 rows. So now you see the beauty of this pd.merge function, which executes a join. It's a very simple, concise, effective way to combine multiple datasets about the same entity. Now let's open up a new section and call it pd.merge syntax. Let's learn about the syntax for this merge function. So as you've already seen, the merge function takes 2 primary arguments. So I copy and paste that there. And the arguments are actually left first. So left equals, here we set that to equal people, and then right. So this is saying what data frame do you have on the left? And this is saying what data frame do you have on the right? So if we run this, we see we get the same output as before. So you can either write the code like this with the arguments stated explicitly, or you can write it without the arguments stated. So you're matching positionally in that case. Okay. So let's put a comment here and say the left and right arguments. And let's open a new code section now. And let's put a comment here for the on argument. So this argument defines the key to be joined by. And what do I mean by that? Let's take a look again at people and test info. The key is going to be whatever column in this pair of data frames that we actually use to do the matching. And as you can see in this case, that's going to be the name. So let's copy this and paste it here. And here we're going to explicitly state that argument. We say on equals, and we give the name of the column, which is just name in this case. And as you can see, we have the same output. So this tells you that the on argument is optional as long as your key has the same name in both datasets. So let's see what happens if the key doesn't have the same name in both datasets. And for that, we had previously defined a data frame called test info different name. So let's print that and see. So as you can see in this data frame now, the key actually has the name called first name. So the name of this column is first name. And so if we tried out our previous code, this is going to give an error. Let's just try it out and see. Open a new code chunk and let's combine with test info different name. And you'll see it says key error name. So what do we have to do in this case? We have to supply the left on and right on arguments. So left underscore on, and this is going to be the name of the key in the left data frame, which is still just name. And the right on argument is the name of the key in the right data frame, which in this case is first name. And now when you run this, you can see that you have a correct output. But notably, Pandas has preserved both name columns, both name and first name. And this is normal behavior. This is to be safe in case there were any rows that weren't matched. We'll talk about that in a few minutes. But now with all that in hand, you are ready for a practice question. So in this practice question, you have 2 datasets, employees, which has some employee IDs, and then training sessions, which has some dates of training for those employees. And I want you to try to predict how many rows and columns are you going to have after you join or merge these 2 datasets. Then go ahead and join them with pd.merge and check your answer. And here's another practice question. Here we have customer details. So a list of customers with their IDs and also their order records. So these are some items ordered by these customers. And you need to join these 2 datasets. And notably in this case, you're going to need to use the left on and right on arguments, because the customer identifier columns have different names. So pause the video and try that out. Now let's make a new section and call it types of joins. So in the examples we have seen so far, in both the left and the right datasets, you have the same records for Alice, Bob, Charlie on the left and Alice, Bob, Charlie on the right. But for real data, that is often not going to be the case. The records you're going to have in the left and the right data frames will often differ. And so we have 4 main types of joins to handle this kind of situation where the entities differ across the datasets. These are the left join, the right join, the inner join, and the outer join, sometimes called the full join. So let's see how to implement these with the pd.merge function. And we'll start first with the left join. To illustrate this, let's pull up 2 data frames. So the first one I'm going to pull up is called people, which you've seen already. That's Alice, Bob, Charlie. And then let's also print test info Xavier, test info underscore Xavier. And as you can see in test info Xavier, we replaced Charlie with Xavier. So now the records on the left and the right data frames don't match. And so when we're joining these, we need to take into account what should happen in that case. So let's open up a new code chunk, type pd.merge. We set our left data frame as people, our right data frame as test info Xavier. And now we're going to use the argument how. So as you can see in this nice pandas definition documentation here, you can see that how can be left, similar to a SQL left join, right, outer, or inner. So let's set it now to the string left and see what happens. Okay. So as you can see in this output now, in a left join, the data on the left data frame is prioritized. So remember that our left data frame is people, our right data frame is test info Xavier, and in the left data frame you have Alice, Bob, Charlie, ABC. In the right you have Alice, Bob, Xavier, ABX. And when we join with the left join, you can see that we dropped the guy on the right that wasn't matched. So Xavier wasn't matched, so we dropped him. But the guy on the left is Charlie that also wasn't matched, we keep. And let's see what happens if we swap the order of the data frames. I'm sure you should be able to predict. So here let's grab test info Xavier and put that as our left, and then people now is our right. And if we run this, you can see now that Xavier is prioritized because Xavier is in the left data frame and the left prioritizes the left. Okay, so with that in hand now, try this practice question. So you have two data sets, students, and the exam dates for some of those students. And I want you to join them using the left join. So in this case, the students data set should be your primary data set. So pause the video and try that out. Now let's open up a new section and call it Analyzing African TB Incidents and Health Expenditure. So this is going to be a more realistic application of the left join. So imagine we are doing a study on tuberculosis or TB in Africa, and we have this data TB 2019 Africa. So this was defined in the code chunk at the start. So let's run this cell and we can take a look. So you have each country and then the number of cases. I think this is per 100,000. And then a confidence interval. And we would like to join this information with information on health expenditure. So we got from a different database the health expenditure for all countries in 2019. So you can see that here, there's 185 rows. And we want to combine these two datasets using a left join. So here's a question for you. Which of these datasets should be on the left? The dataset on the left is going to be our primary dataset. You can think of that as the core dataset that contains the entities that you care about the most. So of course, in this case, since we want to study TB in Africa, then the African countries are the most important. So those are going to be on the left-hand side. So let's do that left join. pd.merge, then TB 2019 Africa, health expenditure 2019. And let's see if we need the on argument. I think the names are the same. So country here and country there. So we don't need the on argument. But let's specify that we want to have a left join. So how equals left. And let's run this and see what happens. So as you can see now, we still have the same 46 African countries. And if you look at this rightmost column, the expenditure USD. So this is the information we've joined from Health Exp 2019. You can see that there are a few African countries where we couldn't find their health expenditure data. So Mauritius has an NA for that row. South Sudan has an NA for that row as well. So Comoros and Mauritius are very small countries, and South Sudan is a new country. So maybe the database where we got health expenditure 2019 from is not yet keeping track of this information for those countries. And it's important that we know this because now we can go look for the data for those specific countries, maybe from another database. If we had failed to specify this how equals left, then pd.merge would have used the default, which is inner. And when you run that, you'll see you have just 43 rows. So the rows that didn't get matched are completely dropped. And so we've lost some of our African country data without keeping track of what happened to it. So that's not good. So typically in data analysis, your core data frame, your primary data set is going to be on the left, and you're going to use a left join to join other information to that. Okay, so with that in hand, here's a practice question for you. So we're going to have two data sets, TB cases children, and this contains for 200 countries, the number of cases between 0 and 14. And then in a separate data set, you have the country continents. So here you have the name of a country in English, the continent, and also the region. And your goal is, as part of your analysis, you want to add this regional information to the TB cases dataset. And the question asks which data frame should be the left one, which should be the right one. And once you've decided, go ahead and join the datasets and observe your output. So pause the video and try that out. Now here is a nice illustration of what happens during a left join. As you can see, the data on the left, Charlie, is getting prioritized and Xavier gets dropped. And for the data that could not be joined for Charlie, we fill in with NAs. Now let's quickly talk about a right join. So the right join is going to be the mirror image of the left join. And right joins typically are not very used in data analysis. But let's copy some of our old code so we can quickly illustrate this idea of the right join. I'll copy this over here, pd merge people test info Xavier. And instead of how equals left, we're going to set how equals right. And let me quickly print just people and test info Xavier so you can remind yourself of what they contain. So people has Alice, Bob, Charlie, ABC. Test info Xavier has Alice, Bob, Xavier, ABX. And so try to guess which records are going to persist after we run this merge function. So if I run it now, as you can see, Xavier is preserved. But since we don't have the demographic information for him, we don't have his age, then that is NaN. So the right dataset is prioritizing the data on the right. Now, of course, you can easily get the same output by just using a left join and flipping the order of the data frames. So this is going to give us the exact same thing as just doing test info Xavier first, then people next, and then we set how equals left. And there we have the same output, so Alice, Bob, and Xavier. So because the left and the right joins can be used to give the same output, and the left join is a little bit more intuitive, typically data analysts don't use the right join. Left join is more intuitive because it makes sense that your primary dataset, the dataset you care more about, should come in the first position. So the primary dataset, it makes sense for that to be this left dataset. So again, if I run this one, you can see that the records on the left, test info Xavier, are preserved. At the left is the primary dataset, so the left join makes a bit more sense than the right join. And so we won't give you a practice question on the right join so you don't get attached to it. Let's look at another join, which is the inner join. So what makes the inner join distinct is that it only keeps in rows that are actually matched. So any row that isn't matched in the inner join is going to get dropped. So let's see what we mean by this. We're going to write pd.merge, or I'll just copy it up from there. So copy this code. And instead of how equals left, we set how equals inner. And try to guess how many rows we're going to have when we run this. You can see you only have two, Alice and Bob. So because Charlie does not have a correspondent in test info Xavier, and Xavier doesn't have a record in people, so we drop those two, and we only keep the intersection. So now here's a practice question for you. So we have data on product sales in this total sales data set. You have the product and the number of units that were sold, and you have product feedback. So for any product, you have the number of positive reviews and the number of negative reviews. So I want you to use an inner join to combine these datasets. Then answer the question, how many products are there in common between the two datasets? So the answer to this should come for free after you do the inner join. And then answer which product has the highest ratio of positive reviews to the number of units sold. I'll tell you that the answer to this should be laptops. Hello, this is Kenneth from the future. This should actually say desktop. So the product with the highest ratio is desktop, not laptop. So you can use that to check your work. Pause the video and try this out. Lastly, let's look at the outer join. So let's copy the code from our inner join practice and paste it in outer join. And we just change how equals inner to how equals outer. And let's run this and see what happens. As you can see, in this case, all the information is preserved. So we keep in all the records, Alice, Bob, Charlie, and Xavier. And if we couldn't find their match in the relevant dataset, we just fill in with NaNs. So you're going to use this join when you want to preserve information from both datasets. And for those of you who remember learning sets in high school, this visualization may be useful for you for understanding the joins. So the left join is keeping everything in the left circle, right join is keeping everything in the right circle or right data frame. Inner join only keeps the records that are common to the two data frames, and full join will preserve everything. So let's review our learning objectives. By now, you should understand how each of the different joins work, left, right, inner, and full. And you should be able to join simple datasets together using the pd.merge function. So congrats on learning the basics of this very useful skill. In a future video, we'll look at slightly more complex joins. I'll see you there. Bye-bye.
For more resources, visit our website where you can track your progress access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.